Hello, this is a tutorial on 4.182 PBA 56, finding factor pairs. Just kind of a fun worksheet. Take a look at this first one here. It's telling you how many factors there are. So let's see, we could have 18. Well, we could have 18 times 1. We could have 2 times 9. We could have 3 times 6. So the total number of factors there are 6. Next one, 21. Well, we could have 3 times 7, or we could have 1 times 21. Total factors there are 4. And so you work your way on through these like this. Here's 13. It's kind of a weird one because it's prime, so it could just be 1 times 13, which is 2. Kind of fun. Look at 500. There's not as many factors for 500 as you think there would be. What, you want to do it? Okay, let's do it. Well, we can do 1 times 500. We could do 2 times 250. We could do 3 doesn't go in there because 5 plus 0 plus 0 is 5. So we could do 4 will go in there. 4 will go in there 125 times. 5 will go in there 100 times. Let's see, what else would go in there? 6 won't go in there because 3 didn't go in. 7 goes into 490, so 7 is not going to go into 500. 8 goes into 400, but 8 doesn't go into 100, so 8 won't go into 500. 9 won't go in there, sum of the digits. 10 will go in there 50 times. And let's see, 11 won't go. 11 goes into 4,400, so it won't go into that. 12 will go into 48 or 480. Sorry, I may have said 7 goes into 4,900, but I meant 490. 12 goes into 480, so it won't go into 500. 13 goes into 540 because it's 13 goes into 520. 4 times 13 is 4 times 13 is 52, so it goes into 520, so it's not that. Let's see, 14 goes into 420, but it doesn't go into 80, so it won't go into 500. 15 goes into 450, but it won't go into 500. See where we're getting here? 16 goes into 480 because 16 goes into 488, so it's not going to go into 500. 17 goes into 510 because 17 goes into 51, so it's not going to go into 500. 18 goes into, let's see, 540, and so no, it's not going to go into 500. 19 goes into 390. No, that's not going to go in there. 20 will go in there. 20 is going to go in there 25 times, and that must be the last one. So the total number of factors, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors. All right, taking a look at some of the questions down below. Which numbers are multiplied to form, numbers that are multiplied together to form a product are called? These are called factors. Which of the tower of numbers has exactly 2 factors? 1 times 67. 37 times 1. 1 times 1. They're prime numbers. The prime ones. Numbers that have exactly 2 factors are called prime numbers. I guess this is prime numbers. In this one, which towers have numbers with exactly 2 factors? I guess we have to go back and answer those. I guess they want us to put down 13, 37, 1, and 67. numbers that are squares of integers. Numbers that are squares of integers. Well, those are called just square numbers. Oops. Started to write it in cursive and then print it at the same time. Numbers. Which of the Tower of Numbers have an odd number of factors? You can go through and list the ones that have odd numbers. And numbers that have an odd number of factors. Go back and look at 25. 25 had 1 and 25 and 5 and 5. So it really just has 1, 25, and 5. It only has 3 factors. Because of that square number, it repeats itself. List all the prime numbers less than 20. Well, these are just the numbers that have two. 1 is not prime. 2 is actually prime. 3 is prime. 4 is not. 5 is. 7 is. 8 isn't. 9, no. 10, no. 11 is. 13 is. 14 isn't. 15 isn't. 16 isn't. 17 isn't. And 19. These are the prime numbers. And list all the perfect squares less than 101. Well, 1 is a perfect square. 4 is a perfect square. 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. And that's 8 times 8. 9 times 9 is 81. And that's it. Oh, less than 101. 10 times 10 is 100. There's your perfect square numbers. All right. Good luck with the rest of the worksheet.